Posing purposeful questions is the most important element of any pursuit, progression, or practice. Our very notion of making a truth claim, a proposition, is phrased as the essence of a question. If a statement is capable of being true or false, which is the definition of a proposition, when we state that it is one or the other, we think of it as asking whether it is true or false. It is as if it remains in that indeterminate state, waiting for the world to falsify it. Such a petition is propped up by premises, places, so to speak, where induction is cogent enough to be called given. Notice how these descriptions prompt more questions themselves. Given under what circumstances? In other words, cogent in what sense? What if Z, Y, or X factors were present? I have a notion of responding to any statement whatsoever with compared to what, according to whom? A kind of skeptic's laser shiv tucked under my sleeve at all times. The instinct to state what we perceive, to report our findings, that is coupled tightly to our instinct to circle back and petition our senses again for clarification, perhaps for iconoclasm, the supersession of our knowledge, analogous to the rising of our heirs to replace us. Why write it down, if not to ask for peer review? Wouldn't a sturdy dogmatic truth speak for itself forever? Ludwig Wittgenstein begins the Tractatus with, "The world is all that is the case. It is not the totality of objects, but of facts." Distinguish an occurrence from a fact, then. An occurrence which is only moving objects can pass unknown to conscious agents. The fluff of snow falling off a branch outside your wall, for example. Only when it is perceived and recorded by such an agent, by an act of the will, is an occurrence coded as a fact. Moreover, fact derives from the Latin word for done, which to some readers will imply a doer. More blooming questions. On one level of analysis, we are making the world one step at a time, as we discover new features, conditions, and relationships within it. But importantly, the very nature of such progression implies that we are constantly testing our new findings and superseding them with still newer ones. My notion of it is having a mountain underfoot, then seeing another mountain on the horizon and seeking to put that mountain underfoot. Questions are therefore the mechanism by which we grow. Our global schema turns and cascades, graduating paradigms at light speed, or the speed of our neurological synapses anyway. Identifiable consciousness has evolved from inanimate to insentient to perceptive. Its discourses from descriptive to figurative to normative. Now, still, the very definition of growth is determined by the craft of the curious, the skill of asking, pursuing, and solving. Every joint in the process, every change and interrelation is framed and fastened by questions. I call inquiry the trusses and sinews of knowledge. Hence, I believe I do not overstate the case as I propose that educators invite students to come alive with questions, the evolution of the conscious scientist continuing at each classroom workstation. Educators do not teach facts, at least not for the most part. "Good morning, class. Here is a bunch of done things for you to know of. Take your time, though. None of them change." Rather, educators offer an apprenticeship in posing purposeful questions. If knowledge is justified true belief, picture how we establish belief, conditions of truth and justification. Questions. Google coherence versus correspondence theory of truth for more about those conditions of truth, and Gettier problem to read up on the problem of justified justification. Questions. In this semester's second grade math lessons and exercises, I have forever emphasized, I do not see getting the answer as the goal. I'm done, as they always say. I'm curious how you got it. Show me the important numbers you started with in the problem. How did you get these important numbers of your own when you were working on the problem? What else do you think we could say about it? Do you agree with Sue about this answer? Did anyone get a different answer from John? How? Why? These students are inured of the sense that their answers, even if correct, do not matter as much as the process that they are using, or as often is the case, and you see it happening in these very worksheets approaching to get them. Every answer a student shows me, correct or incorrect, is met with my response. Why? How? From my students, I want productive struggle, progress through different steps, multiple points of entry, descriptions of reasoning processes, and varied answers to the problem, which prompt discussion among the students, comparing their work, and yes, prompting each other to ask and answer meaningful questions. According to the National Council of Teachers of Mathematics, to pose purposeful questions in the context of the math class, teachers must choose the right types of questions and ask them in the right pattern. This triage is typical of any methodical inquiry, and I will describe how I have applied it in my placement classroom. When one of my students answers a question or solves a problem correctly, I keep my poker face on and I ask them how they got their answer. Then the front lines march into me. I just knew it. I did it with my brain. I am smart. My counterattack, I gently shake my head, smile, and say, "Show me." At this point, wheels turn. Introspection activates. Calculations are reconsidered. Methods are examined. I wait for evidence of all of this. Diagrams, manipulatives, symbols, equations, or strategies must emerge from the exercise, otherwise we are not doing mathematics. Recording an answer without reflecting on how we obtained it is a bit like memorizing a recipe but never making the cake. Importantly, we ought to be able to test our own work. What if we made a mistake? How do we check? We check by evaluating our own reasoning process, by asking questions about questions. Doing mathematics means learning the universality of proven methods of analysis. It means being not just endowed with their use for the application at hand, but with the generalization of their utility to any applicable context. In defending a right answer, students will explain, elaborate, or clarify their thinking, including articulating the steps in solution methods. I skip counted by tens, then ones, a student tells me, in defense of her answer. 2 dimes and 2 pennies gives us 22 cents. Correctly reading a face clock showing us the time 2:30, another student explains, the minute hand goes 5 minutes each number, so I skip counted by 5s and at 6 got 30. What I mean by generalizing the utility of methods of analysis in these 2 examples are the ability to count any combination of coins and the ability to tell the time on a face clock any time of day, respectively. The NCTM reminds instructors to ask clarifying questions, the pattern of which, as already mentioned, is essential. I truly use the Socratic method, particularly when students either have a wrong answer or are stuck. When, during my problem-solving lesson, most of the students were stuck, I did the solution on the board for the whole class, asking one mathematical, epistemological question at a time, what to do at each step, and leaving it to the students, though incrementally, to solve it themselves. The soccer coach has 42 soccer balls. A full bag holds 10 balls. Get back to your seat. He wants to have full bags, but he can have one bag that is not full. What is the smallest number of bags that he could have? Make sure to show your work with diagrams, counters, number lines, or equations. Okay, most of you had tally marks, so we are going to go over that here. Please, eyes on the board. Where are you supposed to be right now? Kylo. So how many soccer balls does the coach have? 42. I am writing tally marks for the soccer balls here. By the way, how do we count tally marks? Skip counting. By what? 5. Let's do it then to make sure we have it right. 15, 20, 25, 30, 41, 42. Good. Let's check the problem again. The coach wants full bags, as many as he can. So how many balls fit in a full bag again? 10. So let's use our tally marks to mark full bags. How do we do that? Okay. Well, we want full groups and we want full bags, right? Yeah, yes, yeah. What if we mark them in groups for the bags? Groups of 10. Does the problem tell us the coach can have a bag that isn't full? No. Are you sure? Let's get our answer from the problem itself. Kylo? The coach can have one bag that isn't full. So, can we have a bag that is not full? Yes. Okay. Then, can the coach have a bag that has 2 soccer balls in it? Yes. Are all of the coach's soccer balls in bags now? Yes. Are all of them but one full? Yes. Then let's count the bags for our answer. 1, 2, 3, 4, 5. Good job. Please hand in your sheets to me. Your names will be sanitized per FERPA regulations. Kylo, no, thank you. Walking feet. Try again.